difference in the room. All right, good morning, everyone. I was kind of worried, like an 8:30 session. I was like, it's going to be like me and like one other person. I'm like, it's 8:30 in the morning, it's Vegas. I'm like, people, who knows what they were doing. Then I remembered, the tenny party is actually tonight. It's if my session was tomorrow at 8:30, then I would have been in trouble. Then there would have been nobody here. My name is Eldon Christensen, and I am a program manager in the Windows Server organization, and I own the failover clustering feature that you see in Windows Server. So I help drive the high availability story for Hyper-V and also SQL and Exchange and file servers. And I do a lot of focus on, obviously there's kind of three features when you think about the private cloud or the Microsoft's private cloud story. There's kind of three principal features that kind of come together here. Around Hyper-V, obviously being the hypervisor. Failover clustering being the distributed infrastructure for our private cloud story. And then obviously System Center and Virtual Machine Manager being the management story on top of it. So doing sessions like this, it can be difficult there's a wide range of people in the audience. So I tried to kind of throw, when I was putting this deck together, kind of a mixture of different things. So I've got some high-level strategic stuff. I also put in a few stuff where we're going to drill down and do some under-the-hood sort of technical stuff for the technical people in the audience. And I also tried to inject some kind of maybe some little-known stuff, or little-known or very lightly documented. So I thought that might be some. So my hope is that everybody comes out of this with at least a nugget, that you get some value coming out of this. So I have a mixture of stuff as I go through this. So when you think about sources of downtime, obviously there's many things. You can think about software bugs. Those never happen, right? Hardware bugs, hardware component failures, site outages, natural disasters. You got to do maintenance. You got to patch. And actually, I kind of love this one. This is my favorite picture, right? There's this human error. So I think that's just a fun one. So in this session, we're going to focus on what are the tools in your toolbox with Windows Server 2012 that can help you build a resilient cloud infrastructure. And we're really going to focus around a couple different scenarios, and we're going to talk about the feature sets that snap into these scenarios. So you're going to have planned downtime, unplanned downtime, and then we're also going to talk about disaster recovery. So at a high level, so let me talk about what are the tools in the toolbox, kind of in these next two slides, and then we're going to start drilling down into them. So at the highest level, when you think about what are some of the tools in Windows Server 2012 that can help me eliminate downtime when it comes to planned downtime. So planned downtime is I need to patch a system, I need to put in an indic, I need to make some sort of a change to the physical server. Live migration is one of the tools that can enable a zero downtime story for planned maintenance. So what live migration does is it actually moves a virtual machine from one physical server to another one, and that moves run state. So it's moving the server side, what's running within physical memory of the box, from one server to another one. On the storage side, we have storage migration, which moves VHDs or VHDXs from one piece of storage to another one. When we start talking about unplanned downtime, and I'm going to walk through these scenarios throughout this deck, we're going to talk about failover clustering, which is the mechanism, which is the technology that I own, which is what we use for monitoring the health of servers, monitoring the health of virtual machines, and when things go wrong, taking recovery actions and restarting it somewhere else. We're going to talk about Hyper-V Replica around disaster recovery, and we're going to talk about multi-site clusters and how you can use them to achieve disaster recovery resiliency for your cloud. On the Core OS resiliency features, I'm not going to go into, actually some of these I will and some of these won't, but let me talk about some of these different things in your toolbox. So storage spaces. So storage spaces is a new feature in Windows Server 2012, and it enables you to take a set of physical disks and create them into resilient, think of it as kind of a software resiliency. So taking a set of physical spindles and creating them into software RAID sets. Check disk. So, who's ever been burned by check disk? Have you ever been burned by check disk? A couple hands here, a couple hands. Yes. So the infamous check disk. So if you ever known in the past that you have some sort of data corruption on your drive going on, and check disk is running, your volumes are offline, it could take hours, it could take days, and you don't know when you're sitting here standing it. So here's my big one sales pitch. If there's any one reason, you could say maybe you're running 2008, you're running 2008 or 2, or hopefully you're not still running 2003, but maybe you got some of those laying around. And you say to yourself, why do I want to go to Windows Server 2012? There's all kinds of cool features. There's storage, live migration, there's blah, 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 blah. But if there's one thing that you want to go upgrade to Windows Server 2012, is that you never have to lose another hour of sleep in fear of check disk. So check disk has been radically improved in Windows Server 2012. So your check disk story in all the previous releases that you've known for the last decade has been that you could be running check disk for hours or days. Check disk in Windows Server 2012 will take like a maximum of around 3 seconds. So check disk times are significantly improved in 2012. And what is the reason for that? I'm just going to go off on a tangent for a second. So in Windows Server 2012, what we've done is what does check disk do? So what check disk actually does is when it has been detected, is there like weird feedback coming, or is this just me? Is this just me? Okay. It sounded weird. It maybe just bouncing back weird at me. So what check disk does is that there is suspicion that the volume is corrupt. The dirty bit is flagged on a volume. And when it goes and mounts that volume, it actually goes and grovels through every single file, every single directory, looking for corruption, and then if it finds it, it fixes it. So what's changed in Windows Server 2012 is that the analysis portion can now be done online while the server's up and running. So now if a volume is detected as corrupted, the operating system will actually go through and look through every single file, every single folder, and identify the corruption and log it and say, aha, I have found corruption, here it is. So now all that has to happen is when you reboot, or when you are on a failover cluster, you fail over the disk, all that has to happen now is fix the corruption. So you no longer have to find the corruption, and that was the big time-consuming operation. So now check disk, that's very, very fast. So if there's any reason you go home and you say, I need to upgrade to Windows Server 2012, from an availability perspective, that is a massive reason. Okay, so now let's go back to other things in Windows Server 2012. So in Windows Server 2012, one of the new features we have is inbox NIC teaming. So in the past, we always had a third-party solution, third-party story, I should say, that you had to use a NIC vendor solution. Now we're really trying to own the stack end-to-end, and so now we have an inbox solution. And that protects you from resiliency of an individual, say, network failure. So we're talking about component failure. On the HBA side, we have MPIO, nothing really new. We've had that for a couple of releases now, and no massive improvements there in Windows Server 2012. And then when it comes to application availability, so monitoring the health state of applications running within virtual machines on top of your private cloud. We have a couple different solutions around guest clustering and VM monitoring, and I'll talk about those here a little later on. All right. So let's dive into the scenarios and go a little deeper. Let's talk about planned downtime. So again, one of the big tools in your toolbox and features in Windows Server, it's in 2012 and it was also in 2008 R2, is around live migration. So live migration will allow you to move a virtual machine from one server to another one with zero downtime. And it has zero perceived downtime to the client. So let me take a little step back. So one of the first things people do when they run out of here, when they're playing with live migration for the first time, is the tool they commonly use is ping. Is they go home, they set up a server, and they initiate a live migration, and then they do a ping against it, and then they drop a packet. And so then they instantly send me an email, and I go, Eldon, you said this was all seamless and no user downtime, and holy moly, I'm dropping packets on a ping. So the key point here is I'm going to talk about how live migration works in a second. Is that when you think about live migration, TCP is the layer that makes live migration seamless. TCP reconnects. So when you go to testing live migration and you want to prove it to yourself that it really is seamless, make sure you use something TCP based. So, and that's what you really care about, right? Use SQL, dual file copy, run your real app. Because what a ping is an ICMP ping, which works at the IP layer, and that's actually not actually using TCP. So that's my one disclaimer. So the scenarios where you use live migration.
May I have your attention, please? The alarm you have just heard is part of the hotel early alert system. The reason for the alarm is now being investigated. We will keep you advised. Thank you.
Wow. This is the first. I've done lots of presentations, and this is the first.
May I have your attention, please? The alarm you have just heard is part of the hotel's early alert system. The reason for the alarm is now being investigated. We will keep you advised. Thank you.
I keep having hope it's going to stop. I'm like, it's just going to go one more and then stop.
May I have your attention, please? The alarm you have just heard is part of the hotel's early alert system. The reason for the alarm is now being investigated. We will keep you advised. Thank you.
Please, no. Oh.
May I have your attention, please? The alarm you have just heard is part of the hotel's early alert system. The reason for the alarm is now being investigated. We will keep you advised. Thank you.
Please, no. Please, no. Oh, there it goes.
May I have your attention, please? The alarm you have just heard is part of the hotel's early alert system. The reason for the alarm is now being investigated. We will keep you advised. Thank you.
So let's give it a minute and see if it turns. I don't know what we're quite supposed to do. I don't know if this is like a fire alarm and we're all supposed to leave, or if, but they're not saying to leave.
The alarm you have just heard is part of the hotel's
And I kind of can't talk over it. I guess I could try, but it would probably be.
investigated.
You just go? You just. All right, this is going to be incredible, but all right, we'll see if I can maintain my focus. You guys want to keep going? You want to try it? All right. All right. Wow. Okay, so live migration. So, as a cluster guy, one of the things in the past is that people are always telling me they wanted clusters to be bigger and bigger and bigger. And so, and I'd say, well, why do you want huge clusters? And what it really came down to was the aspect that they wanted a cluster to be the boundary of a live migration, right? They want to be able to move a VM anywhere in their data center. Now with Windows Server 2012, one of the new features is that you can actually move a VM anywhere. So you can move a VM from a standalone to a cluster, from a cluster to another cluster, and you can actually go from a cluster to a standalone. So now with your private cloud infrastructure in 2012, you can now move a virtual machine anywhere. So that's one of the big key value props now in 2012. So let's talk about how a live migration works. So a live migration is a user-initiated process. I'll talk about a little later how live migration can be automated and kicked off by automated tools. So that's the first thing, is a user initiates a live migration. So how does live migration work? So the first thing that happens is that it's moving the run state of a virtual machine. So let's say you've allocated 4 gigs of RAM to a virtual machine. What it's going to do is it's going to take those 4 gigs of RAM and it's going to copy it from one server to another server. So it's going to take that 4 gigs of RAM and push it across the network as a big giant file copy. So that's the first step. So you got 4 gigs of RAM or however much gigs of RAM allocated to the virtual machine, and it copies it across the network. So while that copy is happening, that takes time. So I'm going to make this up. Let's say it takes a minute to push those 4 gigs as a file copy across from one server to another one. While that's happening, that VM is still up and running. Data is still changing within that virtual machine, right? As users are accessing and modifying and changing that virtual machine. And we're tracking what's going on within that virtual machine. So what we do is then we do that first file copy. Let's say that takes 60 seconds to push those 4 gigs of data across. And then we come back and we say, okay, how much data has changed in the last 60 seconds? And let's say it's maybe 500 megs. Let's say there's 500 megs of changed virtual memory within that 60 seconds. Then we grab those 500 megs and we push the 500 megs across, the change in the 60 seconds. Now obviously we've got a smaller set of data, so that copy goes faster. Let's say that takes, 15 seconds, right? So then in that 15 seconds, data changes, but the data gets smaller, push it across. So what happens is live migration keeps making multiple loops. It'll actually make loop after loop after loop, and each loop, the data set gets smaller, and the time it takes gets smaller, until finally we get the amount of data down very small. And then what we do is we just do a final cutover of the virtual machine, where we actually pause the virtual machine, and then we push over the last set of data, and then we cut over the client. So the client will reconnect over to the other side. So it's this transition right here that a lot of times people, if they're using an ICMP ping, they'll be like, whoa, whoa, I saw a ping get dropped. I saw a packet get dropped. And that's right, because what we do is we do this fast cutover, but it's within the TCP reconnect window, so it's seamless. Oh, yes. That challenged my presentation skills to a new level. Wow. Okay, now we have some focus back. Does anybody want to ask a question on that? Because that was incredibly distracting as I went through that. Anybody want to ask a question about live migration, how it works? Any questions? You got it? Okay, yes. Yeah, so when I'm talking about, so from this perspective, let me go back. So great question here. So let me repeat the question. So he's asking the question about what if I was using virtual fiber channel? So when I'm talking, so with a live migration, I haven't gotten to a storage migration yet. With a live migration, the data on the back end doesn't change, so it doesn't matter what your storage topology is, iSCSI, fiber channel, whatever, it doesn't matter. All that's changing is the run state between the VMs, servers is moving, and the network connectivity between the client and the server. So I'm talking about the Ethernet connectivity client server and the TCP reconnect window, which is usually within about 20 seconds or so. All right, so now that we've talked about live migrations, one of the new features in 2012 is that we can do simultaneous live migrations. So in 2008 R2, we could only do one live migration at a time between one server and one destination. Between source and destination, there's going to be one live migration going on either side at a time. Now in 2012, we support simultaneous live migrations as you can stream multiple VMs off at a time. By default, the configuration is set to 2. But you can go in and modify it to whatever you please. Now, if you crank up the number too high, it can actually have negative impact. You may not get what you want. So let's wield this power wisely is kind of what I said. All right, so let's talk about it. Here's a customer. We had a customer go do some testing. Customer did some testing. Actually, a customer did this testing and sent it to us. Sent to me, excuse me. And what he did is he did some testing on his hardware. Now, obviously, results are going to vary greatly based off of your deployment. Whether you're using a 1 gigabit NIC, 10 gigabit NIC, InfiniBand, whatever you got, your pipe between the nodes is going to make the big difference. Whether you're using RDMA enabled, actually that doesn't apply to live migration, I take that back. Yeah, actually SMB3, it doesn't apply to live migration, it has its own protocol. So I misspoke, I apologize. So what they did is they had they did one live migration at a time. They had 32 virtual machines up and running, and they did one live migration at a time. And they found the time it took to drain it was around 18 minutes. Then they went and they set it to 3 simultaneous live migrations at a time, and they found it took, around 10 minutes, so they had a big improvement. Then they said, hey, let's get crazy and set it to 32 live migrations, all simultaneously streaming at the same time and see how long it takes. And it actually took longer than if you did them serially. What is the reason for that? If you think back, if you heard through the beeping and the moaning through the live migration slides, remember that what live migration is doing is that it's taking that memory and copying it over, and then again, however long that takes, it takes the change data, pushes it to change data, and pushes it to change data. So what happens is that if you're streaming a whole bunch of live migrations all at the same time, we're all pouring through that pipe, each one is going to take longer. That means that does that make sense? So instead of maybe 60 seconds to do a 4 gig memory copy serially, maybe it takes 90 seconds because you have a bunch of them all streaming at the same time and fighting for contention on the network. And as a result, you're pushing more data across because, right, you're going to have to do more passes because each one takes longer and you're not able to get it through. So does that make sense? Yes? Nods? Yes? Okay. So that's why I say, yes, we can support parallel live migrations. Yes, you can do as many as your heart pleases, but don't go too crazy or else you may find it actually gets you worse performance than the other way because it takes more passes, more data, and you may actually get better results if you do fewer. Recommendations. So the Hyper-V team did a bunch of testing, and they found that with modern hardware, we kind of recommend, a good recommendation we found was around 4. So we set it to 2 as like a conservative number. That's the default in the box. And that's more just because somebody could be using like a really slow 1 gigabit NIC, and so we set it to a conservative number in box. but you can crank it up to 4 pretty successfully. So if you walk out of here and you got some decent hardware and you're not just like playing with a pair of laptops, 4 is a good number. So let's talk about some features that leverage live migration and how they use it. So let's talk about failure scenarios. I haven't talked about failover clustering yet, but I will in a few minutes. But the way failover clustering works is that in the event of a failure, let's say you have a server and you walk up and the power supply dies. I know you got redundant power supplies, but let's say the thing catches on fire and melts. What's going to happen is that failover clustering is going to detect that failure, and it's going to want to move those virtual machines that were running on that host somewhere else. Failover clustering is about making fast decisions. We need to go, whoa, that server is now gone. We need to move those VMs somewhere else, and we need to be fast about it because we're an availability feature. We need to fail those VMs over fast. So we try to make some very fast placement decisions and get those VMs up and running as fast as possible. What dynamic optimization is a feature within System Center. It was introduced in System Center 2012, in Virtual Machine Manager 2012, and it actually comes along and makes better, more intelligent placement about where the virtual machines within your cluster should be placed. So what it does is it comes along and it looks at CPU, it looks at memory, it looks at disk, and it looks at storage, and it looks at all the nodes within the cluster, and then it goes and rebalances things. And it uses live migration to seamlessly, with no downtime, start moving things around and balancing out your cluster so that if you've got one node in there which is being pegged with really high CPU utilization, that it's, whatever's running in that virtual machine is just pounding that host. Let's move those things around and spread out the load. So that's a great feature, which uses live migration. Power optimization. Did I skip a slide? No, here we go. All right, power optimization. Power optimization is also another feature, new feature. I shouldn't say new, it's in System Center and VMM 2012. It also leverages live migration. What it does is it manages for power. So imagine this. Friday night, over the weekend, right, you're a 9 to 5 normal shop. Over the weekend, those servers are sitting there pretty much doing nothing, but you're chewing up a whole lot of power. Power is one of the major costs in the data center. So you want to conserve power and costs over the weekend. So what you can do is, this is a feature which allows you to define that, let's say on Friday at 9 o'clock at night, when pretty much everybody's gone home, you can actually go and, let's say you had a 30-node cluster up and running, which you can do. So now in 2012, we support up to 64-node clusters. And you can actually define, and what it will do is it will say, well, all these nodes are running at like 10% utilization. Let's save some power. So let's use live migration to seamlessly, with no downtime, start draining nodes. And we'll move those virtual machines off and get some nodes so they have nothing running on them. Then let's power those nodes off. So Friday at 9 o'clock, let's power them off. And we'll shrink down and we'll squeeze down those VMs to fewer hosts, and maybe we'll power off half the nodes in the cluster. So we're going to save a lot of power and a lot of money over the weekend. Then come, let's say, 5 a.m. on Monday, just before people are about to start walking into the office, then what it will do is it will start powering on nodes, right? And then it will start rebalancing out those VMs across the nodes in the cluster. So this can be very powerful. That was a little bit of a pun, but pun intended. Very powerful, some features that leverage the power of live migration to, without downtime, balance your cluster, balance out virtual machines across your private cloud, can shrink your private cloud and grow your private cloud as your demand is. So just some things to think about. Patching. So in Windows Server 2012, there is a new feature called cluster-aware updating. What cluster-aware updating does is it allows you is an orchestrator for patching. It also leverages live migration. So effectively what it is that you have a patch orchestrator. So here's my patch orchestrator. So a user can initiate this, or it can be scheduled that, let's say, Patch Tuesday comes out. A whole bunch of patches get thrown up on Windows Update, and you want to be able to patch your private cloud. So what it will do is that it will go out and it will, so the orchestrator will go and it will go out to, it will analyze the nodes in the cluster, and it'll figure out what patches are on these machines. It will then go and look at Windows Update, and it'll see what patches are available. And it will determine the delta of what the machines have and what they don't have and they need. So then what it will do is that it will go and drain nodes. So it will pause them, and it will use live migration to move the virtual machines off. Once it has it totally drained, so there's nothing running on it, so it's zero downtime, it will then patch the host, reboot the host if necessary, verify the patch is successful, then resumes it and moves those virtual machines that were there running back, and then steps onto the next node. And then it will then serially walk through every single node in the cluster. So the key beauty of all this is it enables you to, come Patch Tuesday, which used to be this big user-intensive manual process to get your servers and your cluster and your private cloud patched, is now a fully automated process and with zero downtime. So let's talk about storage migration. What storage migration does, so everything we were talking about at this point was about leveraging live migration and various tools and mechanisms that leverage live migration that can really help reduce downtime. Storage migration is about moving, that was about moving the run state server side. Now we're going to talk about storage side. So storage side, storage migration enables you to move a VHD or a VHDX between one disk and another disk. That could be a disk, this could be two fiber channel disks presented to the same server. These could be disks on a cluster, which are shared. These could be even disks between servers which are not connected. So I could have server A with a local internal SAS drive, and I could have another server with an internal local connected SAS drive, and I can then move and do a storage migration between those hosts and move the VHD from this one to this one, and then I can do a live migration to move the run state. So I can completely, actually, we call it shared nothing live migration, which actually does a storage migration and a live migration together, which can completely, between a standalone host, move the VHD and the VM run state between two servers. So the scenario here might be, maybe you have a LUN that's getting full. Maybe you have a LUN that the queue length is getting too high. It's too heavily utilized. You want to move off some heavy workload. You bring in a new array, you drop it in, you want to be able to move everything off. So this allows you to move VHDs around your storage infrastructure. I didn't mention, if you have, so another new feature in Windows Server 2012 is that we now support storage copy offload. What copy offload is it allows you to, or ODX offload data transfer, is it allows you to move a file between two LUNs. So what does a normal file copy look like? Is you have, let's say, a disk, copies the file up to the host operating system and then back down to the disk, right? So you got to go disk to host to disk, and so you got to transverse the SAN twice. What a copy offload data transfer does is it allows you to copy files between disks and with it being just a storage side. So if the storage array supports offload data transfer, it will then do a file copy. So you say copy a file from this disk to this disk. It all happens storage side. So it's incredibly fast compared to copying it from disk to host to disk. It's just disk to disk, and it's actually an offloaded operation within the storage array. And again, check with your storage vendor. If they support it, not all support it yet, but a lot are doing like firmware updates and adding support actively. So offload data transfer is a general feature in Windows Server. So any file copy operation can take advantage of it, and we'll take advantage. So it's not just specific to Hyper-V, but Hyper-V storage migration is integrated with it to take advantage of it. Yeah, it'll just be a whole lot faster. You know, it'll be like, just like magic. The question was, how do you know it works? It'll just be like, it's magic, it just goes fast. But you'll notice a huge perf improvement, you know, so, but otherwise it's not a toggleable, there's a register key to flip it off if you want. So you could test it that way. There's a reg key to turn it off within the host. It's actually not a reg key, it's an fsutil command, I think. But you could turn it off, and then you could turn it off, and then you could do a file copy, and then you could turn it on, you could do the file copy, measure the difference. Sure. You can see the real value of it. So let's talk about how a storage migration works. So a storage migration is just like a live migration in the sense that it is a manually initiated operation. So a user goes, hey, I'm going to move this VHDX from this LUN to this LUN. Now remember, the VM is up and running. Clients are accessing the virtual machine, and we're going to do this live on the fly while everything's up and going. So the first thing that happens is during a storage migration is that a new VHDX is created on the destination drive. So it is a new VHDX which is created. It is empty. There is no data in it. So it goes and kind of pre-provisions this VHDX. And then the next thing that happens is that all reads are continued to be serviced from the source VHD, right? Because that's where the data is, and there's actually no data here yet. So all reads always come from here. But anytime there's a write, all new writes will actually be written to both disks. So it'll be written to the original disk, and it'll be written to the new disk. So what's happening here is, as writes are happening during the storage migration, new data is getting populated here. Yeah? Are there, say it again, are there... Yeah, it's effectively kind of doing like a synchronous replication between the two. Excuse me. Did that answer your question? So writes are being written to both locations. Then what it does is that there is a file copy between the original VHDX and the new VHDX of all the unmodified data, right? So new data that's being written will all be here. We track which data has not been modified and then take the unmodified data and push it across. And again, this is just a file copy. So if this was an ODX-enabled array, it would use ODX. If you are doing I didn't talk about this. It's the last bullet over there. So if this disk, so in this scenario, I've got two disks locally attached to the same server. Maybe it's Fiber Channel, maybe it's iSCSI, whatever it is. But this single server has visibility to both the nodes, to both disks. Excuse me. If this disk was mounted on another server, another standalone host, let's say it's an internal drive, we use SMB as a transport to do a storage migration. So I got my wires crossed a little bit. So live migration at the beginning, remember I talked about, does not use SMB as a protocol transport. A live migration has its own protocol for doing that. But a storage migration will go over SMB between hosts which do not have connectivity to the same storage. So that will take advantage of RDMA. That will take advantage of SMB3 in 2012. That will take advantage of SMB multi-channel streaming between the hosts. Then the final, phase is that once all the data is synchronized, it will then do the final cutover. And it doesn't do the final cutover until it is verified that all data is there. So this is our mechanism that we switch the VM over once we're working off the new VHD, and once we're verified that it's up and functional, then and only then when everything is completed do we delete the VM on the source. And that enables us that if anything goes wrong any way along the process, that we can roll back to the original, right? Because the original was has all the original data, and we were replicating all writes to it. All right, let's talk about unplanned downtime. So when planning for unplanned downtime, in scenarios that we think about unplanned downtime, yank the power cord out, bug check, server catches on fire and melts, right? So something unplanned happened and we need to recover. So what happens is that failover clustering is a feature in Windows Server 2012, been around for a long time, that actually monitors the health of the servers between the nodes, between a set of servers. And then in the event that a server crashes or becomes unavailable or hangs even, we are doing constant health monitoring and heart beating to that server. And if it becomes unresponsive, we take recovery action, which effectively is to kick that node out of the cluster. Then we will determine which virtual machines were running on that host and start them somewhere else. Now, unlike the scenarios we were talking about before, which were zero downtime scenarios, for planned maintenance, live migration and storage migration are zero downtime to clients. Everything keeps running zero downtime. The experience is that when you have a unplanned downtime, is a hard restart of the virtual machine. So we'll detect, we're heart beating, we detect that a node has gone away, it has hung, it has crashed, something bad has happened to it, and then we will go and all those virtual machines that were running will then effectively just be restarted. They'll be rebooted somewhere else. Does that make sense? So it's a hard restart. So there is a little bit of downtime during a unplanned downtime. So what kind of health monitoring are you doing up and down the stack? It's actually pretty pretty verbose across between the nodes. So if you kind of walk the stack of what we're doing, so we have this kernel mode driver called netft, and we're actually doing heartbeating and monitoring between the nodes in the cluster. So that if a node becomes unresponsive, bug checks, hangs, crashes, whatever, we will detect it, we will kick it out of the cluster, and then we'll take recovery action. The kernel mode driver is then heartbeating with the cluster service. That detects scenarios such as a user mode hang. So if user mode becomes hung in the server, kernel mode will detect that user mode is hung and will actually bug check the box to recover. So if anybody's ever seen like these, clustering will do these bug check 9Es. It's really just user mode health detection, which is kind of weird that you'll get these kernel mode bug checks because of a user mode hang. It's like the only scenario that happens. But that's our recovery mechanism. And then the cluster service is actually monitoring up into the MMS service, into the Hyper-V service, which is then monitoring the virtual machine. If that virtual machine becomes unresponsive, we will detect it, and we will restart that virtual machine. Through the integrated components, we actually reach up into the virtual machine. So we actually, through the integrated components as a service running within the virtual machine, we will detect if that virtual machine becomes unresponsive. So if the virtual machine becomes unresponsive, we will then restart the virtual machine. So we have, if you kind of walk this up, we'll detect between failures between nodes, failures between kernel mode and user mode, failures between services, failures of the virtual machines, failures of the operating systems within the virtual machines. So what does this protect us from? I actually kind of covered this. We can survive host crashes, VM crashes, hangs, so I already kind of covered all that. I'll just keep going. So another thing I just want to mention, this actually doesn't fit into the, I just want to mention this. So one of the things that people always say to me when we talk about deploying a failover cluster is the cluster solutions they knew a decade ago, or maybe you knew a decade ago, were these $1 million solutions where you had to buy these very high-end hardware in order to accomplish it. And I guess the point of this slide is I just want to say there are many different solutions that you can use to deploy a shared storage architecture. Between using, fiber channel, traditional fiber channel, lower cost iSCSI, FCOE, you can use SaaS, shared SaaS, which could be either using spaces. You can also do file-based storage. So that's the real big scenario we're pushing in 2012 is using file-based storage. And there's replication solutions, from software-based replication solutions to hardware-based replication solutions to software-based. Look at Exchange or look at SQL. They're doing application-based level replication. So I guess just the big misnomer I want to distill is to say that when you think about deploying a highly available solution, there are many storage architectures to select for your private cloud infrastructure. All right, let me do a quick demo here. All right, so I'm just going to do a quick walkthrough of what does it mean to set up like a highly available virtual machine. All right, so I'm just going to kind of do the soup to nuts real quick. So all I've done is I've got Windows Server 2012 here. I've installed the failover clustering feature. If you want to know how I've actually got this hooked up, this is a cluster sitting in my office back in Redmond, and it is basically just 2 desktop machines. Actually, it's 3 desktop machines. It is 3 normal desktop machines, nothing fancy. And basically what I've got Windows Server 2012 installed on 2 nodes, and then on my 3rd server, it's not even a server, it's just a standard desktop, which is running the iSCSI software target. And so I'm using that as shared storage up to these 2 other servers. So if you want to go home and just create a test system, easy way to do it. You want to have one sitting in your office that you want to use for playing around for test or dev. Anybody can create a cluster these days out of anything. You can even do this with virtual machines. Let's say you just have a single box, you want to spin up 3 VMs, you can do it that way too. Yeah? Yeah, SMB is definitely the strategic direction we're going. This is just, I just happen to have this running in my office. It means nothing more than that, so. And it's more that I've had it set up this way for the last 5 years, so. I'm just an old dog historically that way. So I installed the failover clustering feature. So once you install the failover clustering feature, you will see our Failover Cluster Manager, get installed. And then I'm just going to go and create a cluster real quick so you can see this. So here's our Failover Cluster Manager. So what I do is I just go create cluster, and then I give it the nodes in my cluster. And it goes out and connects them. Like I said, I just got 2 servers. You can see they're actually in the Redmond domain, back in my office. It prompts me if I want to run validate. So validate is a functional test tool when you set up a cluster. So it basically goes and verifies the set of servers or set of machines are all intercompatible. I'm not going to run it in the sake of time, but let me show you just kind of what it looks like. So it's a tool. It goes, and so here's the report at the end. It pumps out this HTML report for you to take a look at. And in here you'll see we try to make it very easy to see, oh, I got a warning. So warnings, so there's either success, green check mark, everything's beautiful. Warning, I'm not really sure, you should go take a look at this. Still supported, might be fine, you should go take a look. And then red X means failed, not supported, not going to work, you got to go fix this. So then you can just click on things and you could say, so here's a warning. I can click on my warning and say, hey, this resource is in an offline state, which means this thing isn't running and you probably want to go fix this. So that's all it's telling me here. So here I get a bunch of some resources in an offline state. It's going, you probably don't want those on an offline state. You probably want to go fix them. So it's a pretty, and we check a whole bunch of things to make sure. We check the hot fixes are the same across the nodes, and we make sure they can all see the storage, and we do a bunch of stuff. All right. So normally you'd run that, but just for the sake of time, because that can take a couple minutes, I'm going to say no. Then you give it a name. And that's it. So it is creating my cluster. Connecting my resources. Creating my computer objects in Active Directory. There's my disks are getting created. It's firing everything up. And we're done. All right. And here's my cluster. So I got a cluster that's up and running. You can see here's my nodes. And I've got some networks attached to this thing. So the next thing I'm going to do when setting this up is I strongly recommend using cluster shared volumes for pretty much everything. So you're going to go in and you go under disks and you're going to see your disks which are within this cluster. And then, let's see, here's a couple of disks. One of the cool new things we have in 2012 is you can multi-select. So I can just right-click, select a bunch of disks, and I'm going to say, actually, let me show you something first. So with cluster shared volumes, if I go to my C drive, I go to my cluster storage, I have nothing right now. So what cluster shared volumes is it's actually the next slide, is a clustered file system that we have in Windows Server 2012. It takes some shared storage and presents it up to all the servers within the cluster so they can all access it and they can all access it simultaneously. So you can have multiple virtual machines running across a set of hosts which are all accessing this LUN. So if I just go in, I right click, I select a bunch of disks, and I say add to cluster shared volumes. And it's now converting these from being traditional cluster disks, which were presented to a single node, to a shared disk across a bunch of them. And actually one of them failed. And then I can say information details. Oh, I forgot to format this disk. So that one didn't get added to cluster shared volumes. So I'll have to go format that one. So if I go look at this, I can see here's my cluster shared volumes. And I can go in and I can see here is data on those drives. And if I go to any node in the cluster, I will now see those same C cluster storage volume 1, volume 2. All right, so now that I've created my cluster, I've taken my storage and I presented it up with all my nodes. Yeah? So the question was, can I do a cluster shared volumes on an SMB share? And the answer is sort of, kind of, yes, no. So let me talk about that. So here's, in the way you would deploy your private cloud so the strategic direction, so as the comment over there, is that the strategic direction we're pushing is around file-based storage. And the way to deploy that is that you'll have your compute nodes, your Hyper-V nodes, which are all using SMB storage. So then they will use SMB and they will connect to a back-end file server. So that will be using SMB, and SMB by itself, by its nature, is shared. So that'll be doing shared SMB down to a set of file servers. On the back end, on the storage side, the strategic direction is around using a new scenario we have called the scale-out file server in Windows Server 2012. With the scale-out file server, it allows those SMB connections to come in and they're actually load balanced across those set of servers, those new file servers. On the back end of the file server, you'll have shared storage, and that will be CSV. So that's why I said sort of kind of yes, because it's technically not at the compute layer, but if you look at it end to end in the stack, CSV is in the stack, it's just at the back end on the file server side. That makes sense? I needed like a diagram or a whiteboard for that one. That was a good one. Exactly. So his point was, okay, so what is the advantage of doing file-based storage? So why are we pushing file-based storage? And a lot of it is really founded around cost. So if you think about, you're going to deploy a 64-node Hyper-V cluster. You can use then commodity, inexpensive Ethernet network cards to do SMB connectivity instead of having to go buy expensive fiber channel HBAs and putting it in every single one of those servers. And so that simplifies, it reduces costs. It also is it simplifies the configuration. You don't have to worry about going and reconfiguring your SAN and presenting it from to all those nodes, doing all the LUN masking. You probably have large organizations will have a more segregated IT infrastructure where maybe you have SAN admins, right? And they manage the fiber channel infrastructure, and they would own managing storage connectivity to the scale-out file server. But then the server admins are empowered to create the SMB shares and manage the SMB connectivity from the compute Hyper-V servers to the scale-out file server. Does that make sense? Absolutely. So the question was, yeah, I can use these cheap, inexpensive pizza box, Hyper-V servers, do a massive scale-out with inexpensive and low interconnect cost, low management cost. Absolutely. That's exactly it. Yep, you nailed it. Yeah, so the question was, how many CSVs should I have? And that's kind of a magical question. So there's two aspects to this question. The first part is depends on your storage array vendor. So the first part is go talk to your storage array. No. All right, I'm going to keep going. All right. I'm going to like tune out and try to see if I can do this. Okay, so CSVs. I'm going to try to ignore this. Okay, so some storage array vendors, with a modern storage array, they'll tell you, we don't care about it's a very simple question about what sort of IOPS does the storage array need to deliver. They'll say, you know what, it doesn't matter if you create 1 LUN or 50 LUNs. We have tiered storage, we've got tiered storage, and we're intelligently managing, placing the data on the platter, and we don't care how you do the data. Wow. We don't care where you put the data. Some other vendors with some other arrays may have very different answers. They may go, oh, wait, no, if you need to have this sort of IOPS, we need to think about how many spindles do you need, what kind of RAID sets are we going to create, how many do we need? So those sort of decisions may define how many CSVs you need. So some based on your IOP requirements. So that's my first answer. The second one is around backup. So when you go to do backups, with Windows Server 2012, it's all about... So we have a distributed backup infrastructure for CSV now in Windows Server 2012 that we will actually call across all the VMs that were running on an individual disk, quiesce up to the Hyper-V writers, into the writers within the virtual machines to get app-consistent snapshots distributed. And so that can also affect how many virtual machines you have, where those virtual machines are running, and then doing those distributed backups. So that is a really long answer to my short answer to that is a good number is like maybe 1 CSV per node in the cluster. So maybe if you had a 10-node cluster, you'd have 10 CSVs for each node in the cluster. But you could technically do one, but then again, then the second half of the answer is go talk to your storage vendor, because some will say, cool, you want to do one LUN and put everything on it, rock on, we'll intelligently handle it on the back end, and some other storage vendors will have a heart attack. So, yeah. So good. So the question was around manageability. So that's actually the entire reason we designed cluster shared volumes. Was the problem we had in 2008 was that you had to create one LUN per VM, and that just became a management nightmare. If you had 100 VMs, you needed 100 LUNs. If you had 1,000 VMs, you needed 1,000 LUNs, and that was a nightmare. So what we tried to do was, that's where the entire business decision around creating cluster shared volumes came from, our business need, was to reduce the number of LUNs. So we went from hundreds or thousands down to just a small handful. So that will drive it too, yeah. So maybe you have a dozen disks, and that's much easier to manage. Did I answer your question? Okay. But I was agreeing with you. I think it was more of a statement that I agree with you. Actually, in the sake of time, here, let me do this real quick. Okay, so I've got a CSV. I can then go virtual machines. I can do a new virtual machine. I pick my node that I want to create my virtual machine. Pops up the Hyper-V wizard used to. I want to store my VM on my CSV volume. So I go to cluster storage. I'm just going to allocate. And let's actually, just in the sake of time, we'll do this. So actually, there was a second half of your question which I didn't answer, which is why I got the puzzled look, which now I understand. It was around, can I storage? So can I? Then you can. If you have, that's another good question. A good point. If you had multiple CSVs, then you could be using storage. You could be monitoring the. So having fewer CSVs is good because then you'll have better space utilization. If you have a whole bunch of LUNs, then one LUN runs out of space. But then you can use storage migration to move across. You could be monitoring IOPS of an individual LUN and then be using storage migration to migrate across. So there's pros and cons. Pros and cons. I'd probably do more than, you could do one. One would be fine, or you could do one per node. So it's a great question. So do we have a dynamic optimization for storage? We have dynamic optimization, which is monitoring the server side and moving things around, and that's kind of analogous to VMware has their DRS feature. VMware also has a storage DRS features, which uses storage vMotion to move VMDKs around on storage, and which is actually something we don't have today. But it's, I can guarantee you, something we're thinking about. Another question? No, there is no feature in 2012 or 2012 SP1 around doing automatic storage, kind of a storage dynamic optimization. That does not exist today. We do not have that feature set today. Okay, so I've created my virtual machine. Here it is up and running. And then you can go in and you can do things such as you can do live migrations and move it to another node. And I can live migrate this one across. It's going to go fast because I have a very small amount of memory allocated. I only put 512 megs of memory on it. Over it goes. That took just a few seconds. And I can also do, here's how to do a storage migration as well. So you can do a storage migration to move the virtual machine from one set of storage to another piece of storage. Okay, in the sake of time, I'm going to flip back because I got some more slides and I'm running out of time. The evil beeper has thrown off my timing. CSV, so the CSV not only helps solve management problems, but it also increases resiliency. So why am I talking about CSV in my cloud availability session? So it also increases availability. Let me talk about that. So here's a node, which a cluster which is up and running. I've got a set of servers connected to some storage. Here's my VHDX. VM running there, and this one is my thing we call the coordinator node or orchestrator within CSV. So with CSV, you can walk up and you can actually yank the storage cable out of the back of the server. You can say, well, I've got MPIO, and I've got dual redundant connections, so why would I need that? But you've got your evil admin who's really clumsy, and he kicks out all the cables. What CSV will actually do is it will detect the storage I/O failures, and it will route them over another path to keep the virtual machine up and running. So what will happen here, here's the scenario. You walk to the data center, Bucky the evil admin trips over the fiber cables and knocks them all out. That VM, we will detect the storage failure, and what we will do is then we will route all the I/O for that virtual machine over SMB to another node in the cluster, which will then execute the I/O on its behalf. That's pretty cool, I think. That virtual machine will stay up and running with no downtime. Now, to hook all the scenario together, you can take you can say, aha, I have a node which is running in a degraded state. I can then take live migration and live migrate and drain that node of all virtual machines so that I can go fix it. So that's pretty cool when you hook it all up together, right? Okay, so let's talk about application availability. So guest clustering. So what guest clustering is it is creating a cluster. So you've got your private cloud infrastructure. You've got a bunch of virtual machines. You've got applications running within those virtual machines. You may have even higher levels of requirements for availability for those applications running in those virtual machines than the natural HA characteristics of Hyper-V and clustering will provide for you, of all the failover clustering at the host layer. So what you can do is you can actually create clusters at the guest level between the virtual machines. That brings you two big things. It brings you application health monitoring. So you're monitoring the health state of SQL. You've got an important SQL database. You're running in a virtual machine on top of your private cloud. You want it to monitor the health state of that SQL so that if it becomes unhealthy, it will take recovery actions. That's the first thing it will do. The second thing that a guest cluster will bring you is application mobility. What that means is that if that virtual machine, SQL becomes unhealthy, you can then fail over SQL from one virtual machine to another virtual machine. This is also handy for things like if you need to patch the guest operating system. You need to patch the guest operating system. You can then fail over the application, SQL, from one virtual machine to another virtual machine so that you can do guest OS maintenance within that virtual machine. So how do these things all kind of come together? If you kind of layer these things, you kind of got clusters on top of clusters. So what you'll have here is that you'll have your host cluster, your Hyper-V cluster, and then you'll have your SQL cluster running between virtual machines. You could have those virtual machines running across diverse host clusters, Hyper-V clusters, so that you can have both virtual machines failing over, and you can have applications that can fail over at the guest layer. Another new feature we introduced in Windows Server 2012 is called VM monitoring. What VM monitoring does is it enables, so what I talked about earlier is that with the default inbox health monitoring, we can reach all the way up into a virtual machine and we can monitor the guest operating system, but we can't monitor the application health. So what VM monitoring is it allows you to monitor the health state of the application running within the VM. It allows you to monitor the health state of SQL. Then bubble down the health state of SQL all the way down to the hypervisor level, and then it will take recovery action to restart the VM. So the scenario here is that if SQL becomes unhealthy, we will detect it down here at the host layer, at the hypervisor, in the cluster service running here, and then we will restart that virtual machine. So what is the difference between guest clustering that I talked about in the last slide and VM monitoring that I talked about in this slide? They both solve some of the same problems. So VM monitoring only solves application health detection. So it only solves monitoring health state of the virtual machine. Guest clustering solves application health monitoring and application mobility. You can fail over SQL. A guest cluster, I would argue, is more complex to set up. VM monitoring is very easy to set up. So those are the pros and cons. VM monitoring, easy. So here's the scenarios. I think about my tier 2 SQL databases. I would probably be using VM monitoring. Easy to set up. Go monitor those mass numbers of tier 2 SQL and make sure that the health state is running, percolate it down to the hypervisor so the VMs will restart and recover. For my tier 1 SQL deployments on top of my private cloud, I would probably be doing guest clustering to give me that higher levels of availability so that I can also do patching and recovery at the guest layer. Yeah? Yeah, no, so it's a great question. So the question actually is, so the question was, what about SQL Always On? Actually, SQL Always On is actually a cluster. It just doesn't use shared storage. It can do replicated storage across between the database. So it's kind of one of the things like Exchange. A lot of people think Exchange doesn't use clustering anymore. Actually, it still does. And Always On uses clustering as well. We're just infrastructure. We're kind of hidden these days, which is good. I like that. Yeah. Yeah, so you can do, let's talk about so the question is with guest clustering, what are my options? You can do iSCSI-based storage, and you can do new with 2012, you can do fiber channel-based storage. So those are your two options around doing shared storage to the guest. And you can also, a very good point, you can also do SMB. You can do SMB from the guest, so you can run SQL over SMB, SMB 3.0 from the guest. Absolutely, great point. And we're looking at more. There's a teaser. We're looking at more. Yeah. Excellent point. Excellent point. Another point differentiating the two, just to repeat it for the room and anybody listening in the recording, VM monitoring requires Server 2012 in the guest. And guest clustering you can use with legacy OSs. Excellent point. All right, let's talk about DR. Hyper-V Replica. So Hyper-V Replica is a new feature in Windows Server 2012. And what it allows you to do is to do disaster recovery replication of a virtual machine. So basically what it does is every 5 minutes, it is tracking the changes going on within the virtual machine. It takes a delta of those changes every 5 minutes, and it pushes it across to another site. It is fully integrated, so it is workload agnostic. So there are many layers you can do. So we talked about like SQL Always On. So you can do SQL Always On guest clustering, and you could do disaster recovery at the application layer. This gives you a workload agnostic. So you could be running VMs that are Linux and 2012 or legacy or whatever could be running in those virtual machines, and you can actually have a disaster recovery story, and you can be agnostic. So it's a nice way to have an agnostic disaster recovery story. And so basically what it does is every 5 minutes it's taking a delta of the change and it's pushing it across. The 5-minute replication interval will give you an application, a crash consistent recovery point. What I mean by crash consistent means like if you walked up and yanked the power cord to the back of your server, that's crash consistent. Maybe check disk has to run, but that gives you crash consistent. You can also configure an application consistent backup state within Hyper-V Replica. And then it is actually off by default, but you can configure it, and maybe you configure that in the magnitude of hours. So maybe once a day, so every 5 minutes, maybe you're pushing across, you're getting a crash consistent restore point, and then maybe every 8 hours, 12 hours, you're getting an application consistent. So an application consistent, the difference is, right, it calls into the Hyper-V writers, which calls into the virtual machines. If you're running SQL, it calls the SQL writers, quiesces all the applications, and gets a nice, clean recovery point. But it's more expensive. So that's why you don't want to be doing it every 5 minutes, as it would impact the performance of your applications. Another disaster recovery strategy you can take is around multi-site clustering. So what multi-site clustering is that you have two sites and you have some servers running in each site, and that you have, let's say, a pair of servers running here and a pair of servers running here, and you actually create them into a single cluster. And this cluster now spans across sites. So this is a 4-node cluster which is now stretched across sites. And then on the back end, you can use another form of replication, be it software replication or hardware-based replication. And basically, every storage array vendor out there has a hardware-based replication solution, and they'll all plug into multi-site clustering. So basically what this is that in the event of a failover, then there's orchestration that'll fail over across to the other site, and it will automatically recover on the other side. Let me talk about why would you use one or the other. So if you compare these two, so if you were asking yourself, Eldon, you just talked about Hyper-V Replica, that sounded cool. Now you're talking about this multi-site cluster stuff, that sounds pretty cool too. Which one should I use and why, and which one is right for me? And that really comes down to what are your service level agreements and your business requirements. So if you talk about these two, so Hyper-V Replica, it has a recovery point of a minimum of 5 minutes. What does that mean? That means you are going to lose, you could lose, I should say, it could be nothing, but let's say, you could lose up to 5 minutes of data. With a multi-site cluster, you can actually do, depending on the replication vendor you choose, and whoever your storage array vendor is, they will give you synchronous, they will give you asynchronous, and they can give you 0 data loss guarantees. So that's why I put a 0, but I put a little clause there, depends on it. So, if you are a stock trader on Wall Street, you will probably say to yourself, I cannot tolerate 5 minutes of loss of stock trades or I would lose my job. I need to be thinking about this. Business requirements are driving your decision making. I am setting up a file server for the marketing department and I don't really care if they lose 5 minutes worth of PowerPoints. This is probably great for you. Does that make sense? So that really, so maybe you'll have this for all your tier 2 deployments. So you can say, I have a DR strategy for every virtual machine, for everything that's tier 2. For tier 1, I need higher service level agreements. I need higher guarantees for my online business, for my stock trading, for my way, whatever it is. Does that make sense? So you may use a mixture of both. Another big thing, I didn't talk about this. The RTO, the recovery time. Hyper-V Replica is manual failover. So you have to go and hit the peripheral big red button. When the site fails and everything goes down, a user has to go take administrative action to recover. That takes time. You have to notice. You have to, get alerted. You're in a movie. You have to drive to the data center. Whatever you need to do, right, to go take recovery action. You need to call your boss. You need to have a meeting, and it takes time. And so what ends up is longer recovery times. With the multi-site cluster, everything can be completely automatic and automated. So that means that when a site goes down, everything will instantly, it will be health detected and will automatically switch all the replication. There's integration between clustering and the storage arrays. We'll switch everything over automatically and everything will come up without anybody having to do anything automatically. So that will give you faster failover times, less downtime, and a better recovery time. Does that make sense? And then cost, obviously Hyper-V Replica is in the box, included in Windows Server. You can do it with Standard, you can do it with Data Center. You have to go buy a third-party replication solution, and they're a little more complex, I'll just be honest. Yeah? Hyper-V Replica will also fail back, so once you switch over to the disaster recovery site, it will automatically start replicating back the other direction, reestablish with the source, and then you can do a failback. We don't have the limitations of the other guys. Let me phrase it that way. Sure. So could you automate this? Yeah, absolutely. Could you have some scripts set up? Could you have some automation through Ops Manager or something? Absolutely. Sure. There was a session yesterday on how to do this. Yeah. Yes. So Hyper-V. Hyper-V Replica is totally integrated. Hyper-V Replica is totally integrated. You can fail these virtual machines. These clustering will detect failures and failover virtual machines and will reestablish replication. You can live migrate virtual machines around. This can fail on this side. It's integrated with clustering on this side. You can storage live migrate. Things can all move around. You can do a planned failover from here to here with no data loss. So if you say, hey, I'm going to I'm doing a planned maintenance that I know I'm shutting down this data center because I'm going to go do work on the power lines coming into the building. You can do a planned failover, which will be a 0 data loss movement of the virtual machines to the replica side. Absolutely. And then fault tolerance solutions. People ask this question. Yeah. So the question was, does the replica need to be in the same cluster? And actually the answer is no. Actually the replica will be a different cluster. So actually it has to be a different cluster. So you do replicas between clusters. Where with this solution you do a single cluster stretched across sites. Good question.
How do you maintain consistency between the two active virtual controllers?
Between the domain controllers, you're saying? Let's talk offline. That's a very advanced question. Let's talk about offline. Okay, so let's talk about fault tolerance real quick. So the question is, can I use fault tolerant technology? And the answer is absolutely yes. So some people say, I even have higher levels of availability requirements, and I want to have a fault tolerant solution. The answer is, can I do that? The answer is yes. So we have a partnership going on with Stratus. So we have a third-party story going on around a mission-critical Hyper-V. So basically, if you think about what is a fault-tolerant solution, so it is basically a pair of physical servers which are running in lockstep. And they're running a single common operating system on top of them, and they're running the virtual machine. So they give you great resiliency to hardware failures. So for example, if you had the motherboard blow out on this server would kick in and there would be no downtime. Does that make sense? So fault-tolerant solutions can be powerful. They protect you from a very specific set of scenarios. And if you want those, we have a partnership story around that as well. Okay. So in summary, there's a breadth of features and new features in Windows Server 2012. And there are features in your toolbox for doing planned downtime, unplanned downtime, and covering disaster recovery. So those are all things you need to think about when building a resilient cloud. So there's many different attributes to think about, and that we have solutions for in Windows Server 2012. Okay, and with that, we have 1 minute left. So are there any more questions? Yeah.
I have a scenario where I have a series of particles that unplanned failures, and the cluster function as expected, the VMware plus moves over to others that restarted. The problem I ran into is a number of VMs restarted but started recovering them, and I couldn't find a rhyme or reason why some did and some didn't. Is there a way to stop that?
Okay, so there's a very good question here. There's a very good question in here. Okay, so the question was around, I had a bunch of VMs do a hard failure. When they came over, they were doing recovery, they were running check disk, they had a bunch of different things going on. So here is the important thing to know about. Okay, with a virtual machine, the boot OS is an IDE drive. So the VHDX is attached in, and you have a virtual IDE drive. Some applications have write-through requirements, and the virtual IDE controller does not provide some of those write-through requirements. So, for example, if you are virtualizing a domain controller, if you are virtualizing SQL, for example, the virtual IDE controller will not provide the write-through semantics that it requires. And what you can have happen is that in a hard failure, you can actually have corruption or data loss within the virtual machine. So, when you are deploying Tier 1 applications or applications that have high data consistency guarantees in a virtual machine, you need to use the virtual SCSI adapter within the virtual machine. So if you're deploying a domain controller inside a virtual machine, that means that you create a VHDX, that's your boot drive. You have your virtual machine. You need to create another VHDX, and you need to present that up through the virtual SCSI controller, and you need to configure Active Directory to store its JET database on that SCSI disk. Does that make sense? There are some articles about doing this out there that say when deploying SQL in a virtual machine, when deploying a domain controller, but they're honestly, these points are kind of buried in these big long articles. But that's an important thing to know, that you can have data corruption and data loss occur because the natural way when you configure a domain controller in a virtual machine is you set up you normally would, you got one disk, you don't really think about the fact that it's running over a virtual IDE, and which isn't providing FUA guarantees, isn't providing write-through semantics. So, yeah, that's a great question. Yeah. Yep, cluster we're updating. So, The point he's making is he's going, hey, you Microsoft, you guys get your story straight. You have a bunch of different strategies on how to patch hosts. VMM has a patching strategy. Now in Windows Server 2012, you have clusterware updating. You have a bunch of different mechanisms to patch systems. And the answer is you are right. You are right. No, it is not integrated today, but it's something we're working on. It is not integrated today, but something we're working on. And the real strategy difference, so part of the answer, it's not a good answer. Like VMM can do patching, but it only does patching of Hyper-V. Clusterware updating can do anything. You can do your private cloud, it can do SQL, it can do file servers, it can do anything. So clusterware updating was designed to be a general purpose solution where the patching in VMM is cloud only, Hyper-V only. Yeah. That they don't put in maintenance mode, you're saying? Or, yeah, there were some issues earlier on where they weren't putting it in, but I thought that was fixed. I think it's fixed in the latest version, where they weren't properly putting in maintenance mode. That is true. There was an issue with that earlier on. Okay, and with that, we're out of time. I just want to say thank you very much. I hope you got something out of the session. I tried to put in a bunch of nuggets on different levels, and I really apologize for the alarm. That was a challenge. And please fill out a survey. That's actually very important, so please fill out a survey.